All right, I'm presenting today on a library I call Framian. I like to say it's analytics for small data, mostly because I'm a bit of a programming hipster and don't like to follow the trends of big data.
I can hear the audio from your computer.
I swear I muted it.
No, I can.
Okay, cool.
Okay.
All right, anyways, so I'm the presenter, Tom Switzer. The other two gentlemen listed there have also contributed to Framian or helped me make it, or they were co-authors, I guess, I'll say. So anyways, let's solve it. So basically, oh, that's fantastic. Anyways, don't worry about that.
Don't fix it.
Okay, there was a link there at some point. I don't know what happened. Anyways, basically the open source library that we just released. Just for working with kind of small, I say small. Really, I mean, thousands, millions even. It doesn't really matter. But I mean, it just means it's not on disk. It's in memory. So you have to be aware of those constraints. So it's basically working with tabular kind of data. Keys for us is that it has to be heterogeneous. We don't work with just numeric data. We have dates. We have information for like auditing where the data came from, that kind of stuff. We like to shove this all in one thing and pass it off to our visualization layer. And it works too. Okay, so we actually have a link up here now. So you guys can just furiously copy that down because I won't change the slide right now. Okay, so anyways, disclaimer. Sorry guys. Sorry, a quick disclaimer, which is that this is still very much beta, maybe alpha. So the API is really subject to change, which you will see in a second. And there's, of course, probably a ton of bugs which I've not found yet. For all you non-Scala programmers out there, this is Scala. I'm hoping that it should be easy to follow, and I'll also convince you to switch to Scala. If not, then whatever. So the other thing, of course, is that if you go to Framian and you click on master, you will not see many of the things I'm doing here, because I'm actually using a merge of 3 different branches, which are kind of outstanding right now, but you can still get. But that kind of tells you that things are still subject to change. Alright, so the real main thing that Framian provides is frames. So frames are basically just some abstract way of talking about some tabular chunk of data. And so by tabular, what I mean is like you have basically rows and columns, and rows are indexed by some type, and your columns are indexed by some type. Here we're loading a CSV file. Sorry. And so our column index, or row index, is basically the row number of the CSV file, because that's the most sense you can do from the CSV file. And here you can see that our column index is basically strings, or like a label. So this is basically, when we say two-label frame, we're taking the header of the CSV, and we're using that as our row index. And then you can see here we have our lovely actual data. Critical thing here is that it's not just numeric data or not just textual data, it's a mix of it. So this is really nice. If you are someone in the Scala world and you pay attention to this stuff, you may know that it's kind of looks similar to Saddle, which also has frames. It is fantastic, but the main thing was that all Saddle frames are typed. So if you have a row of type, you have a column index type, but you also have value type. So you can have a frame of doubles, you can have a frame of strings, but you can't have a frame of both things, or dates, or whatever else. All your columns have to be the exact same type, which doesn't really match what we think of when we think of textual data, or tabular data, like something you've seen in a CSV file, or a table from SQL.
Are there generics in Scala?
Yep. You'll see here that we got our lovely frames parameterized on 2 types. So the first type is int, second type is string. So what I was saying is that, so basically Saddle does have a way of dealing with heterogeneous data, and that's just using any, which if you're a Scala programmer, you're probably going to cringe. But they do have some kind of wrappers that basically like, say is instance of kind of stuff for dealing with frames of any. It's kind of terrible, and dealing with this really made most of our use cases difficult and not really worth actually using Saddle, even though it's fantastic, just because it didn't have this basic level of support for dealing with different types of data within the frame. The critical thing here is that we don't actually have a value type for a frame. First, this might seem a little weird because you're like, if you're a JavaScript programmer, you're like, yeah, of course, I would have. But I mean, like, if you're a Scala programmer, you need to talk about types at some point, and you do. So in the frame, you can mix types, but at some point when you actually need to get access to the data, either pull out a cell or get a column or a row, you have to actually then talk about types and say, I want this to be as this type of type. All right, so first thing I'm going to show you is, this is basically just showing you a bunch of little features of this and hoping that you like it. So if we basically call the frame as a function, we can get a single value from the frame, like a single cell. So basically you can see here we want the cell as a double, and basically provide the row that we want, which in this case is the 333rd row, whatever that is, and then we provide the column that we want, which is the horsepower column for our data, which is about cars. And we get back a value. Just here. So you can see that whatever car is at the 330 row has 132 horsepower, which is great. So maybe we want to know what that name of the car here is. So we get the same row, but this time we're going to ask for the column value, or the value of the column, or the value of the name. We ask for a string, we get back that it's adapted to ADZX.
What happens if the name column doesn't have strings in it?
You will see soon enough. I think the next slide. But first, I'm going to wow you with some more stuff. So basically, what happens if we ask for the horsepower column as a string? So this is kind of a unique thing to CSVs. But if you do, it will actually give it to you as a string. This is because the CSV file doesn't actually have, you can't tell just by looking at a column if it's actually numeric data or if it's an ID or something like that. And so Framian actually gives you, it's very flexible in this, and it can let you make choices like this or this. You'll see in a second, anyways. It also has a lot of support for dealing with numeric data rather than just doubles. So if we ask for the horsepower as a big decimal, we get it as a big decimal. If we ask for it as an integer, we get it as an int. Sorry, I'm just a little exhausted. Anyways, basically, the key here is that Framian makes the assumption that you want to work with numeric data and not necessarily a bunch of doubles or a bunch of big decimals. The reason for this is like, depending on your use case, you may want to work with big decimals. If you're talking about currencies, you want to get a column that's big decimal. If you're working with, if you just want to rip out a bunch of features and throw them into a machine learning algorithm, you probably want to get them as doubles, because whatever library you're using, we use doubles for sure. So that's all great. I mean, all these things exist, and it's nice. The question is, what happens when values don't quite line up or don't exist? So our previous one we saw was basically we're getting horsepower for the DATSIM 280ZX. We're told that it was 132. You can see here it actually is 132. So what if we ask for the horsepower for the Mustang Cobra? It's actually not available here. For whatever reason, Ford didn't report it. I don't know. It's not in the data. So we've asked for it. It has to give us something. It does. It tells us it's not available. Which is kind of nice. So basically, yeah, go on. So another sort of example here is what happens if we ask for the name column for the same thing, but we ask for it as a double. So obviously it's not a double. It says Ford Mustang Cobra. It doesn't make sense as a double. So in that case, it tells us the data is not meaningful. So this is kind of nice because basically, I'll give skip slide, sorry. So basically, the core concept here is this idea called cells. So anytime you're dealing with a single value in Framian, you're probably going to be dealing with a cell. And I have a nice little Haskell AT here because it fits on the slide. But basically, it's in Scala, but it's basically the same thing. So it can either be a value. In the case of a value, basically just wrapping some type that actually exists. It may be missing or it may be nonsensical. So it's kind of similar to option, except with option, you only have one option, only one alternative, which is that it's not available. In this case, there's also the case where you've tried to convert a string to a double that doesn't make sense, or you attempted to divide by 0 or something else like that. Whatever the case, your result just doesn't make sense. It's not available, it just doesn't work. Anyway, so that's great. So getting a single individual cells out is kind of, not super useful most of the time. Usually, we actually want to just get out the whole column or a whole row at a time and work with that. And so Framian kind of provides this nice way of getting either columns or rows. And you use, in this case, we're using calls, and calls are basically saying that we want to it's specifying a group of columns you're working with. Then we also provide a way of typing that set of columns. So we're saying that we're dealing with a column called horsepower, and that column is a double. And we want to try, when we access that, we want to try to get the values out as a double. And so when we do that, we get back a series. And so a series is kind of like, how a frame is a tabular data, so it's like 2D. A frame is 1D. So we still have a row index here, but there's no column index, it's just values. But the nice thing is the values are typed. So we do know that our values are doubles. You also see here the cells are coming up again. So a series naturally assumes that data may be missing or not meaningful. And that's kind of built into it. And the first type here, the generic type, is the row index type. So it's how we access values in this series. So another example here is getting, so in this case, when we talk about calls, we're basically defining the way we're accessing the data. So we're using calls, we're doing basically things in a row, on the row access. So here we're getting values out along, the row number for the CSV. If we use rows, we're going the other way. We're going along the columns, and we're talking about a selection of a particular row. So if we get out a row as a string, you see we get one of our records, basically. It has an off-gallon name, all that kind of stuff. Quite nice. So I'm just going to keep going on about this stuff and why this is a nice abstraction. So if you remember before, we basically had this nice way of saying the horsepower column is a double. Usually it's not too useful to work with just one column. Quite often we want to deal with more than one column. So here in this case, we are, instead of getting a single column from the frame, we're actually getting two columns. We want both the name and the horsepower column. And we want to type this as a two-tuple string and double. So you can see that here. So if we do that, you see that we actually get our series. Once again, the row index is the CSV, and our values are actually two tuples with strings and tuples, as you'd expect. Quite nice. For the Scala people, basically it uses using extractors. So when you specify the .as, it basically tries to find a type class that knows how to extract values from a frame and turn them into the type you want. You can create custom extractors. The only ones that really come with frame right now are ones for dealing with h-lists and from shapeless, and then shapeless also generics. It also uses the number of columns you specified to guide the inference. So the reason why that two-tuple example worked previously is because we had two columns, it retains the fact that the call is actually part of the type parameter, is that you have a size of 2. So when you specify a two-tuple, it knows that matches up, and it's happy doing that. If not, you'd get a compile time error. So kind of a nice example of this is using a generic thing is if we have a car, we define a car class here. It has 3 fields, the name, the weight, and the horsepower. We define our way of accessing these, each row to turn it into a car. So instead of saying double or two-tuple, you just say car, and then shapeless, generic magic happens, and you actually get out your case class with values filled in, which is quite a nice way of accessing your data. Anyways, the main point I'm trying to make here is so your rows or your columns, whatever you're using, is a way of abstracting away from this notion of extracting data out of a frame. So naturally, frame just uses this everywhere. All of its columns typically take rows or columns so that it knows which axis it's accessing the data in and how to actually extract data out to give it to you. The other thing is these things are actually, you can just map them to other types. So although the data is intrinsically for the origin, so basically this CSV file has an origin field, it's either 1, 2, or 3, and it defines whether it's an American car, a European car, or a Japanese car. So we have to access the data as either string or int, because that's what it is. But we really just want to, we don't want to know 1 or 2 or 3, we want to actually map that to a name that kind of is human readable. So in this case, we define our way of accessing it. Then we're going to say, well, once you've extracted the value of int, map it to this next value. So you can see that we have our calls as a column type, which is, makes sense because that's our type that we're actually the column index, our headers. And And then the result type is now a string instead of an int, because we mapped it to a string. So I'm going to kind of define these little values here and then use them later. It may be a bit confusing. If it is, just ask me if you can't remember something, I'll go back. But anyways, main thing I remember to define this way of getting our origin out. So now I just want to talk about some of the things you can do with frames. So one of the obvious things is grouping. Grouping in this case is really more like sorting. Anyways, but basically it's just a way of taking a column data or something data and creating a new row index and then sorting your data by that row index. So in this case, we're basically saying that we want to group our frame by the origin. The origin is from the previous slide, so it's not going to use 1, 2, 3. It's going to use USA, Europe, and Japan. So basically, we group it, and we get back a frame, and the row index has changed. We no longer have the CSV type, like the original row index, which was the row number, but now we have a string, which is going to be the origin. And so you can see our data, our row index is now actually the origin, the region of origin. Another thing you can do with frames is you can map them, obviously. So you can take your row, map it, and stick it in a new column. I'm Canadian, so I don't really deal with cubic inches. I wanted to map it to liters. So here we're basically saying that we're going to extract the CI column as a double. And basically, once we get that, we want to stuff the result of whatever our map is into a new column called liters, or L. And basically then so we have a function here. Scala is just a really shorthand way of writing a function, an anonymous function. So basically we're just saying take whatever the value of the CI is and multiply it by some conversion factor that'll turn it into liters instead of cubic inches. So you can see our lovely new frame here now is a new column. Obviously, just for reference, I don't know if I was truncating the frames both by column and row, because slides. So you can quickly take a look, and we have our lovely new frame with our mapped column in it. Here's our liters, obviously a bunch of American cars. Another thing you can want to do with tabular data, and you can do with frames, is join them. So in this case, I'm just going to create a little frame. It's kind of a toy example, but basically I'm just creating a frame with one column and one row, or 3 rows. And so basically the rows are indexed by our region of origin, which, if you remember, that's what we were calling them. And then basically origin labels, just a human readable version. And basically we want to take these and we want to map these all to our original frame, which had all of the cars in it. So basically, by origin was our frame where we group by origin. So the rows are all indexed by like USA or Japan or Europe. We're just saying 10 columns basically means drop all the columns except their name, and that's just because of size. So basically we're ignoring all the horsepower and stuff. We still get a frame back, and then we just say we want to join this frame with the labels, the human readable labels, and we want to do inner join. There's also left outer joins, right outer joins, and outer joins. And so what you get back is a lovely frame of 2 columns now instead of 1 and 1. One's from the by origin, where we retain only the name. The other one's the origin labels, and so now we have a frame that has these things all joined in, and we can access them like we normally would. So another thing, I don't know if you guys noticed, but your indexes are not unique. So I mean, usually at least one of your indexes will probably be unique because it's kind of easier. Like in the case of the CSV, usually you only have one column header. You don't replicate it, but the rows are quite often replicated, or vice versa. And there's a reason for this, which I'll get to very shortly, which has to do with reductions. So basically with frames or series, you can reduce all your values down to a single value. In this case, we're just defining a bunch of our extractors to access, the rows, horsepower, year, miles per gallon, whatever else. So the first case, we're just basically saying, okay, we'll frame, get the horsepower column as a series, and then we're just going to take the mean. So the average horsepower is 104. Just kind of a terrible time to be driving a car. If you get instead, you can also, there's other ones like max. So we can say, well, give me the max miles per gallon. Find out 46, which is pretty impressive. There's also other ones like, unique. So we just basically want to get all the years that are in the data set. And see that only go up to 81, which is why the horsepower, so it's pretty. So that's not really that interesting. What's more interesting is when you reduce by key instead. So this is why your indexes are not unique, is that you might want to have duplicates, and then you want to reduce them down to 1 by whatever the unique index things are. So in this case, we're getting horsepower again, but this time we're saying mean by key. So instead of reducing all the horsepowers, because the row index is the country or the regions of origin, we're instead, for each region, we're getting the mean horsepower. And not surprising, you can see that American cars have more than European and Japanese. You can also do the same thing for the miles per gallon, and we can see that the American cars suffer for their horsepower quite a bit more than they could give. So putting it together, we have this crazy example here, which will turn into a one-liner later on. But you can see here, basically, we're just creating two of the series that we had. We're doing reducing by key. We're getting the mean, and we're getting the count. So the mean miles per gallon and the total number of cars for each country or region of origin. And then basically what we're doing is we're taking our original frame. We're dropping everything with the miles per gallon because we just don't need it. And then we're going to join it with our mean. So this has basically 3 rows, one for each region. So we're going to join that. So now we're going to get a color frame that has our means and our actual miles per gallon. So we're going to then sit here and we're going to get them out as a 2-tuple doubles, which will give us a series. We're going to map just the values of the series. So we have the value and the mean. So we're going to subtract the 2, get the delta, and square it. Then we're going to sum them up for each. This is always by region. And then we're going to basically take each of them. We're going to zip map, which is basically an inner join but for series. And we're basically going to get the standard or the variance, and then we finally square root and get the standard deviation. That's just a very roundabout way of getting the standard deviation. You can see here it's pretty much the same for all of your regions. So it's good to know that each of those values for the mean miles per gallon is pretty indicative of the actual region. Anyways, so given that, some little things of Framian can do. I do want to say what Framian is not. It is not a big data distributed analytics platform at all. I mean, like, it really is just for working with small chunks of data. It works well for our use case because we generate tons of charts that all have data. They don't have a ton of data, but they have a bit of data that has to go into them. We basically need to deal with that small data and do some analytics and then render a chart really fast. The other thing it's not is, this is just from talking to people about it. It's not a linear algebra library. We have no intention of trying to do that. If you want it, you can basically get your rows out as an array of doubles and shove it into a matrix and go wild. But it's for frames that have heterogeneous data, so it's not really working for working a nice generic way of working with matrices. It's also not a stats lib. So we have a Framian stats package that will hopefully get some more stuff. But our real goal here is to provide kind of the basic building blocks that are required to build more complex libraries, like a stats library on top of this. We just want to provide the stuff you need to do that. And so kind of our key stuff here is we have our value extractions, so our calls and our rows, and how to get values out of a frame because they don't have types. We have this notion of index. It's used by both the series and the frames. We have a row and column index, and our series we just have the row indexes. And the indexes provide all the abstractions we use for doing reductions, both reducing and reducing by key. They also provide the generalizations for actually doing grouping and sorting and that kind of stuff, and for also code grouping as well, which is so this generic code grouper class is used to implement zip map, merge, and join. We also have these column types, which kind of basically actually wrap the values in themselves and provide the mechanism with which it decides how it can cast things. And so using these, we're trying to build basically more complex libraries. So Framian stats is one of them. It kind of is very basic right now. Basically provides literally those two things. Etc. is really kind of excessive. But anyways, you can see here, like, that big mess of stuff I had before is replaced by just after standard deviations. Much easier. We have, basically get to do a linear regression here. So this is our independent variable. These are dependent variables. So we're saying we want to try to predict the miles per gallon based on the weight and the size of the engine. And so basically, given that, we can just pump it some, you can give it a car with, 4,000 pounds, nearly 5 liters, gets terrible gas mileage. If you lighten the weight down to 2,000 pounds, it gets significantly better gas mileage. And that's basically it. So we're hoping to get people to contribute, which is why I'm talking about it today, because it is new. So if you're interested in this kind of stuff, do help.
Awesome.
Questions?
Do you filter?
Yes, you can filter. So I left out a ton of stuff. Yeah, filtering is definitely a core thing. You can map groups of rows, so like you can get, so when you have your frame, you have a group by origins. You can get each origin thing as like a separate frame as well, and do what you want with that. Yeah.
How much mapping is of values involved, down, low? What kind of representations do you have?
It's not a ton. Not as much as you probably think, anyways. So I mean, it can be a lot if you have really terrible data and you kind of just shove stuff in there. But I mean, like if you know your data, like you have a bunch of columns of doubles, you basically have an array of doubles in the background with like basically a bit mask for like the doubles, not meaningful. Yeah, and basically, so like there's no wrapping there, and then if there's not a lot of specialization right now because I haven't had the time to get into that. But yeah, you can basically just rip through a column. Like if you look at the code for reductions and code grouping and stuff, it's much more like low level. So you can make reductions and that kind of stuff that are basically literally just accessing like the values that are not wrapped at all, which is obviously a nice way to do it, but it's harder to write reductions like that. So there's also simpler ways of just getting like a vector and reducing it. But yeah, things like the mean and stuff are just ripping through a column of an array of doubles, basically.
When you cast a row to a class, as you did in the
Yes.
car example, and there is no valid value, is that row completely discarded
Yes.
or is supplied?
It'll be an error or something.
Does
Oh, sorry.
No, go ahead.
does Scala have anything like the data frames that are in Octave or R or Python's pandas?
Yeah. The whole thing of this is trying to kind of replicate R's frames as much as we can in Scala. Obviously, we're never going to have the horde of statisticians writing libraries for this, but I mean, like the goal is to provide the same kind of like nice ways of doing it. Like, there's a whole bunch of nice things in R2 for doing like this melting and stuff. We're trying to add that stuff, but it's not there quite yet. But this is trying to add it to Scala.
How do you handle situations like summing massive amounts of data that overflow? If you're expecting it, and back, do you silently ignore the error?
If it's overflowing?
The ends overflowing, you don't choose a big
If you ask for an int and you sum and it overflows, I figure that's your problem. I'm not going to do checked arithmetic. I mean, just because the solution to that is to use a type that checks your overflows.
Sure. So why not disallow all types that don't check for overflows?
It'd be more work on my part. And also, I don't think that's. Also, I don't want to try to prevent you from doing that. I mean, if you want to make a mistake, that's your business. But I figure it's on you to know your data well enough to do it.
In your example where you had the map you can fit into liters, you didn't appear to specify kind of where you were putting the column. Were they just in that order?
No, I think it just sticks it on the end by default. So there's no way to, for the map operation, there's no way to specify where it's going to go. It's here because when I was in the REPL, I had to kind of remove a bunch of columns, but it would normally be at the end here. You can reorder things. You can group the columns if you want, much like you group the rows, or you can map the row index or change it around or whatever.
So if I'm using a CSV file, I'll get the columns.
Yes, you'll get.
It's not going to sort them.
Yeah, these things are ordered in whatever order it sees them in. I mean, like, obviously the rows here are ordered because they're in common sequential order. But yeah, if you have whatever row the CSVs will be in, that's the order you'll get it. Which is important too, because not all CSVs have headers. So like in my case, convert the CSV using two-labeled frame. If you just say two-frame, it gives you both the row and the column index are numbers.
If you have a number of columns, how do you do the casting back to a case?
Same way. So instead of using for your calls here, instead of saying CI, you'd be like 2. Yeah. The types have to match up. So this whatever type you're using here has to match the. If you're using calls, this has to match the column index type. If you're using rows, it has to match the row index type.
If you produce a row by mapping data from one to another, can you then cast it into a different case? So for example, if you had a case that didn't have leaders and a case that had leaders, would you be able to extract a frame into one of those cases?
Not sure I understand. Oh, no, I mean, yeah, the current extractor right now is very basic. It won't do that. It'd be nice to, but I mean, yeah, that'd be nice, but I think it's probably a little more work than I want to do.
Lazy.
Well, I mean, you can always write your own extractors with what you. I mean, for doing the generic, like the basic stuff, like getting out the tuples, which is, I mean, for my cases, are 90% of what I do. This works, but like, yeah, doing like the kind of, co-products of types. I mean, it'd be nice to do that. I think. Worth a try. Maybe I'll do it this weekend and we'll see if it works.
I'm sure you accept patches.
Yes, of course. Anything and everything.